Welcome back. This is the other problem I was talking about, and this is really one of my favorite problems whenever I teach a chemistry class, because this really makes you think, okay? You would no longer be that robot or some kind of a repeated thing that I tell you something, you remember, and then you do it again. But I have not done it throughout the course. I've made you think throughout, but this really is, is the icing on the cake, that if you can do this type of problem, I'll be very happy, because this really has to make you think. It has to connect so many dots in your brain that it makes you think, wow, I can do this kind of thing. All right, so this is the kind of moment that I feel that when you can do it, you have really connected so many schemas, as they say, is storage of knowledge in your brain, to put together a problem, and then you solve it and you decode it, you crack it, and it just makes you feel so good. However, beautiful things or difficult, good things in life, you have to get it through difficult ways, right? So to get through and solve this problem, yes, it is difficult, it is complex. If not, I would have done this first before I did the previous problem, but I know that this is very, very, very difficult. All right. That's because, again, there's layers of information that you have to work one at a time, just like you would work your croissant or puff pastry. There's that layers, or filo dough, that where you have that layers of information. Is that layer of information what gives a good, complete product? Similarly, if you have weak layers of knowledge about concentration, or you don't want to think, then you probably will not be able to do this problem. The requirement to do this problem is the ability to think and act and put that knowledge that you have towards something that you can solve. And like I said, that to me is a sheer joy of being able to do something like that. With that said, let's get to the problem. Sorry for the little philosophy, but I feel that I don't want you to think I'm throwing at something that you've never seen in your life. It's just you should need to know how to bypass and get through things to be able to solve something. All right, let's read the question loud. A solution of 85% by mass phosphoric acid has a density of 1.685 grams per milliliter. What is the molarity of the H3PO4 solution? What is the molality? This is a beautiful problem because it's as literally tied three things: percent by mass, molarity, and molality, along with the density thrown in. Density is not concentration, but it is thrown in there. All right, how do we go about even decoding this problem? Well, start from the beginning. It says 85% by mass of phosphoric acid, and they have given the formula for it, so you don't need to even struggle to do that. So 85% by mass of H3PO4. Okay, now you learned how to calculate percent by mass, but here they've given the answer and you have to backtrack it. If 85% by mass and this is the solute, that means 85 grams of, if 100% is your solution, 85% is solute and 15% is solvent, that means 85 grams is H3PO4, and the remaining 15 gram is, well, you have to assume it's water. Okay, I will do this problem again a different way at a later point of time, but for now, if you say 100% is the maximum, okay, so when you hear coaches say I gave 150%, it never made sense to me. Okay, how can you give 150%? Okay, there's only 100%. Okay, that may be an exaggeration, but again, there's only 100%. That's math, all right? You cannot have 150%. So 85% by mass of a solution is the phosphoric acid. That means the remaining 15% must have been water. If 100% is 100 grams, that's the way I do it. 100% is 100 grams. So 85% is 85 grams. And 15% is 15 grams. That's exactly what I have done here, right? Now we know the mass of phosphoric acid. Now what is, again, don't try to analyze the entire problem in your brain, because including yourself and mine. None of our brains are supercomputers. And don't think you have a supercomputer brain, and you don't, and I don't, and we all should realize that and analyze the problem one step at a time. All right, first step done, right? Okay, now we have the given information of phosphoric acid. Now let's go write what is the question asking. It's asking you to calculate the molarity and also the molality. So let's deal with the molarity first. And the definition of molarity is moles of solute over a liter of solution. Okay. So moles of solute, well, that means we need the mass of the solute first, which we have. And if you go get, but for that first we have to get the molar mass of, actually let me start writing a little higher so I can save all the possible spaces. So molar mass of H3PO4, and I'm just going to use round numbers because that's the way I always done my math and I never had any problems. Phosphorus is 31. Okay, phosphorus is 31. The 3 hydrogen is 3, and the 4 oxygen is 64. So that is 64 plus 31, 95 plus 3, 98 grams over 1 mole. That's the molar mass of phosphoric acid. So if you know 85 grams and you want to find the moles of solute, well, that's your given information. So 85 grams of phosphoric acid, right, divided by 1, and 198 grams goes on the bottom because ultimately we want moles as our answer. So 1 mole goes in the top. And if I divide 85 by 98, that will be 0.87 moles. Okay, 0.87 moles. You do not ever have to repeat it again. The beauty is, I'll show you later. So we know this now, right? Now we just need to find how much of it is 1 liter, right? So we know that this is 85 grams and this is 15 grams, right? So that means we have a total of 100 grams, right? 100 gram is the total mass of the solution, right? We have 85 grams of the phosphoric acid and 15 grams of the water, right? So that means we have a total of 100 grams of solution, right? And this is where the density comes in. So our density is not water. Apparently we've used something else, but we're going to say that that's the density. So this is 1, this is given information, right? Now keep in mind how I got the 100. 100's got by 85 plus 15 because that's the mass of water and the solute and the solvent. That's how I got this. Okay, 100 grams of solution, and then our density value goes on the bottom because we want to cancel out the grams and have milliliter. Why? Because we want liters. So 100 divided by 1.685, and then that's basically 59.34 milliliter. And how much that is in liter? We want it only in liter, no milliliters allowed. So that means 1,000, let me write it here, 1,000 milliliter is a liter. So 59.34 mils will be 0.05934 liters. Good. That's it. We have moles of solute, which is this. And we have, let me get a different color so I can highlight those again. So this, we know the volume in liters. Okay. Well, you know the volume in liters, and we know the moles, so we can now get the molarity, which is 0.87 moles divided by 0.05934 liters, which will be 0.87 divided by 0.5934. So it's 14.66 M, which is for molarity. But we're not done yet. This problem is nowhere near completion until we actually go and complete molality. So let's write that down. Okay, what is molality? Molality is moles of solute divided by a kilogram of solvent, right? Now this is where molality shines. Okay, well, moles of solute, you don't need to calculate it. You only calculate it once, 0.87 moles. And you divide by, well, 15 grams is, right? 15 grams is, you don't use the density. Why? Because density is for the solution, not for the solvent or the solute. That's for the solution. So you only use density when you're dealing with molarity, whereas with molality is even much simpler. Well, how much is our solvent? 15 grams, right? So 15 grams, 1,000 grams is 1 kilogram, right? So 15 grams would be what? That's how much solvent you have. So 15 divided by 1,000. So that is 0.015 kilograms. So that comes over here. So that means it'll be 0.87 divided by 0.015. That's 58 molality. And that's it. It seemed like we rushed towards the end because we had all the information. So setting up was the most difficult part, right? So this is a very unique problem of its kind, and the one before was also unique of its kind, right? You should be able to learn to do both, okay? So again, I don't want to repeat this problem with another replica, okay? That's for easier ones, it might work because we can do multiples, okay? But for a complex problem like this, I think it's better off that you watch the video, rewind it, because if you're gonna get to the end of the video and stop staring at the screen, that's not going to be helpful, okay? Because I try to contain everything within one screen, so it's everything there. So when you go rewind it, the video start from the beginning, and I did it as a separate video. So you just have to go start from the beginning, work your way down one step at a time. Like I said, none of our brains are supercomputers, so don't try that. It's not going to help you. All right, so work it out one step at a time, and then when you finish, write down what is that you don't understand, what you did understand. I guess all of us would understand something from the problem, but we also don't understand something. You write that down and then ask me, hey, I don't know why you do this. I guess it's more of why I do this becomes a problem for these two problems. Until then, everybody is good. But again, this is the larger picture that I want you to learn. And when you go to those professional exams, or even for sometimes you would run into things that you need for your life, and these are the things that you want to know. And this is, so it's not just for this one problem in this class. Ultimately, you also have an option where you can skip this question on a test, where you can just say, I'm going to guess. If you take that route, that's also, you're welcome to do that, but I highly encourage you learn the material. And that's pretty much it for this video, and I'll see you with another video. And in that one, we would learn how to balance chemical equations and then go into limiting reactants from a stoichiometric perspective. Okay, but that's for a separate video, and I'm done on this one video, and I'll see you all with another video, so stay tuned. Bye-bye.